Good morning, friends. This is Durga again from ITversity. So I'm back after a couple of days break, and today we'll be talking about exercise in Scala and Spark workshop, and tomorrow we'll be wrapping up. As I have been mentioning, just a minute. As I have been mentioning, this is just backup for the WebEx session. So let me start the session, and then we will take it from there. Good morning, friends. Let me mute everyone. And now let me share my screen. I hope everyone can see my screen. Please confirm that you can hear me and also you can see my screen. Hello? Yes. Thank you, Revati. So today and tomorrow will be last couple of sessions for Spark and Scala workshop. I'll cover a little bit on Python next week, but with respect to Scala, today and tomorrow will be last. So let me start the recorder. So let me recap what we have covered so far. So we started with Scala, and then we got into Spark. And as part of the Spark and Scala, we covered the entire content between CCA 175 and HDP-CD Spark. So if you go to HDP-CD Spark and go to the objectives, so we have seen everything. We have seen how to write a Spark core application in Scala. We have seen how to initialize a Spark application using set methods such as set master, set app name, and also you can override any other property by using set. And we have seen how to run a Spark job on Yarn, how to create an RDD. Here, it's primarily about sc.parallelize to create an RDD out of a collection. Okay, and then we have seen how to create RDD from a file. So most of our exercises are on this. How to persist an RDD in memory or on disk. I have shown you there are certain parameters with under class name called storage level, where you can say persist or cache with different options. And then transformations and actions is the main one. We have seen broadcast variables and accumulators. Configure Spark properties primarily to override any parameter using set method. And then with respect to Spark SQL, we have seen how to create Spark data frame from an existing RDD. We have to use case classes. We have to apply map and apply case class on top of it so that we can create RDD of that case class type. And then we have seen data frame operations such as filter, group by, filter group, ag, many other data frame operations. We have seen how to write a Spark SQL application. Also, with respect to Hive, we haven't covered ORC, but we have covered rest of the stuff. Probably later today or tomorrow, I will try to get into ORC. And then write a Spark SQL application that reads and writes data from Hive tables. So we just have to write queries to read from Hive tables. Okay, so all these things are covered in detail. So today will be I will give an exercise. I think I already have. Just let me search. Just give me a moment. I think my Google Drive is not synced properly here. So let me see if I have my external hard drive. Okay, just give me a moment. I have an external hard drive. I need to get the document. Excuse me. Yeah. So this is about 5 and 6. So we have 2 here. 5 is compute daily revenue for each day for each department, and also get top 5 traded stocks by volume each month from NYSE data within a given year. So for these 2 exercises, we have to write programs using Spark SQL. Okay. So let me create the exercise. So it's under big data. It's under workshop exercises. Okay, so the new topic will be exercise 08. So there are 2 components to this. Okay, so for the first one, for the exercise 5, what we have to do, we have to create Hive tables for retail DB. Okay, most of you are part of Hive exercise also, and you have already created tables. Okay, for those who are not part of the Hive, let me know. I will just share the create table commands, or you can ask whoever have joined the Hive workshop. You can get the create table command, get your tables created for all 6 tables under retail underscore DB, and then implement exercise 6 using Spark Hive SQL. Okay, so here, if you want, you can write the program using SBT. Otherwise, you can just write the query where you have to join all the 5 tables, such as departments, categories, products, orders, and order items, and then just write the query. And the second one is on New York Stock Exchange data. Okay, and you don't need to create Hive table for this. I will recommend to create SBT project. Okay, so let me break down a little bit here. For exercise 5, create Hive tables for retail DB. Implement exercise 5 using Spark Hive SQL. Full SQL is good enough. If interested, go with the SBT application using IntelliJ or Eclipse with Scala IDE. And then for exercise 6, for exercise 6, create data frame for stock underscore EOD. So where is that data? So here I am logging into the lab to show where the data is, and I will paste the path here. Okay, sudo su and then Hadoop ss-ls public. Okay, in this we have nysc, and you can see the data over here. So you can use this data which is under public nysc in HDFS. Okay, now you create data frame for this data set. And implement exercise 6. Using Spark native SQL. Develop SBT project. So if you need this data, you can copy. So on the same node, you also have on the local path. The local path is /data/nysc, I guess. Yeah. If you are interested, you can copy this directly to your local machine, and you can actually test in your local machine before building the jar file and running on the lab. Okay. Develop SBT project using IntelliJ or Eclipse with Scala IDE. Validate locally. Build the jar file using SBT and then run on the cluster. Okay. So use 2 to 4 tasks. Don't leave to the default values. And I have shown you how to override the number of tasks while executing the queries. Okay. So use 2 to 4 tasks while executing the queries. Run the program on the cluster. Observe DAG stages, executors, and executed tasks. Okay, so this is our topic for this exercise. And also, I skipped one exercise on broadcast variables and accumulators. After the class or after tomorrow's class, I will actually create that exercise, exercise 7, and I will recommend to pursue that exercise also. I explained you, but I never created exercise for it. So I will recommend to pursue that exercise also, especially if you want to give HDP CD certification. Probably doing that exercise will help you. If it is CCA, that exercise and also this exercise are not that important. But from the work perspective, this exercise is very, very important. Even broadcast variables and accumulators are good things to know from work perspective. So if you are interested, you can do that exercise also. So I'm pasting in the chart. Now I will give it to you. You start working on it, and if you run into any issues, let me know at any point in time. Okay, so I'm opening my IntelliJ also. So for Google, for those who are on YouTube Live, I'm pasting the URL for you also, in case if you want to do the exercise. Okay, and let me update the description as well. Okay, it will take time for you. So I will leave today and also tomorrow for the exercise, but I will wrap up tomorrow. Probably I will give half an hour tomorrow, and last half an hour I will wrap up the session. So this is HiveQL. So you can use query like this, but in your case you have to join 5 tables. I just joined 2 tables, but in your case you have to join 5 tables, and also make sure you actually use only 2 to 4 tasks like this. Okay, and for data frames, using Spark native SQL, this is the code. I think I have pasted this as part of the last session. You can improvise your existing program. You can copy till this, but before writing the program, you have to create that stocks underscore EOD case class, and then you have to create a data frame, and uh, and then you have to register a temp table, and then you have to run SQL context, which is nothing but Hive context dot SQL. Sorry, not Hive, SQL native Spark native SQL context dot SQL, and you can write the query on top of the data. So you need to figure out what is the data type you have to use while creating a case class for your New York Stock Exchange data. If it is good idea to have everything in one package. So I will go on to mute. If you have any question, either you can unmute yourself and ask the question, or you can actually ping in the chat. So, so I hope everyone is doing the exercise. Most of you might already have Hive tables. For the first one, it should not take much time. It should be pretty straightforward. So, anyone finished the first task at least, or close to finish it? Hey, anyone close to finish this first task? First task is pretty straightforward. It should not take very long. You just have to join 5 tables. At least those who have some experience with SQL and all, it should not very long time for the first task. Also, if you guys need anything for your reference, let me know. I will paste it in the chat. So there's one question. How do you determine the number of partitions when you set spark.sql.shuffle.partitions? It is very valid question. I think I have explained in the past about how to determine the number of reducers. It all depends upon the number of keys and the amount of data which will be processed by each key will determine the number of partitions for shuffling purpose. For example, if it is states in India, we have 29 states, and if you are trying to process equal amount of data for each state, and if it is huge, then probably you can choose 29 as number of shuffle partitions. If there is a skew in that, you might have to do some trial and error, which number will actually process the data in uniform fashion. Okay, so you have to go through the same way as number of reducers, which I have covered earlier. I'm not sure whether I think I have covered as part of this only. So that actually determines the spark.sql.shuffle.partitions. It all depends upon your data and how much data is processed by each reducer. By default, it is determined to be same as number of map tasks, tasks which execute the map process, and the number of map process is actually determined by the size of the data. Okay, which might not be good number for almost all the cases. At least 80% of the cases, running equal number of reducers as your map task is not good idea. For 20%, it might not matter. So you have to do some homework, understand your data, and then you have to come up with appropriate numbers for spark.sql.shuffle.partitions. Is it clear? If you miss that session where I have explained how to determine the number of reducers, I will reiterate. I will spend 5 to 10 minutes and try to explain how to determine the number of reducers. Or you can also watch the content on YouTube later. Yeah, this is the one. So there I was speaking more about split size and number of reducers from Hive context, but the similar logic apply even for Spark. Okay, and also as part of the last week, I will try to get into more details about performance tuning in general. Yes, Ravindra. Mm-hmm. Yes, yes. Yeah, so there is exercise 5, right? So you have to go to that for reference, and if you go to that exercise 5, yeah, yeah. So yeah, you have mentioned that is correct. You just have to join all the 5 tables: departments, categories, products, orders, and order items, and get the revenue for each day and for each department. Yes, Priyanshu. Can you change it to everyone when you chat? Yes, by default, Spark SQL shuffle partitions is 200. That is correct. But in general, when you run typical Spark program using code transformations and APIs actions, then the number of partitions is based on the size of the file. Yeah, when it comes to SQL, that is correct. I was wrong. You are right. It is determined by the Spark SQL shuffle partitions, which is hard coded to 200. But in general, when you write regular Spark transformations and actions, in that scenario, the number of reducers are determined by the number of mappers, and the number of mappers is determined by the size of your file and the split size. Thank you for correcting me. And also, when it comes to exercise 6, just listen to me. Just give a small pause and listen to me. When it comes to exercise 06, while writing the query is not typical SQL with group by and all. You should know something called windowing functions, or if you are from Oracle background, it is called as analytic functions. So you have to use that here. Okay. So try to write it. I will give the answer tomorrow about how to write windowing functions in SQL, and also as part of the Hive SQL, which is going in parallel as of now. I'll be covering windowing functions quite extensively. Okay, so whoever have knowledge about windowing functions, they will be able to write it easily. Otherwise, you guys might struggle. Don't waste too much of time. I will provide you the SQL, but try to focus on the other stuff about creating the data frame, and then start writing queries on top of it. Then I will give you the query. You can paste it as part of your code, and you can run it. But I will do it. I will give the query tomorrow. Okay, if you as part of exercise 6, we have written dense rank function. So we need to simulate that as part of Spark SQL with the data frames for this exercise, second part of this exercise. So we have 9 more minutes. I'll be right back, okay? So we have 4 more minutes. So anyone have issues with the first query? If any one of you need SQL to create the tables for first query, or Hive script to create tables for the first query, let me know. I will give it to you. You just focus on SQL. Don't worry too much about creating tables and loading the data into it. So 2 more minutes. Okay, so we'll catch up tomorrow and spend some time today and try to make it happen. With respect to the second query, I will give you the query because it's a little bit complicated and you have to use windowing functions to simulate the dense rank. Don't make it way too complicated by writing uh, the query in query using multiple nested queries. Okay, I will give you the query and you just have to use that query and get the output and save it in the files. Okay. That being said, thank you very much, and let me put you on mute for a few minutes, and also I will stop sharing for a few minutes, and also I'm stopping recording. Please remind me if I do not start recording after I come back. Thank you. So those who are on YouTube Live, thank you very much for joining the session. As I have been saying, if you require environment to practice, you can use labs.itversity.com. And if you go to the plans are $14.95 for 31 days, $34.95 for 93 days, and $54.95 for 185 days. And you can start learning through my videos using the lab. Whether you have signed up for the lab or not, if you have any questions, you can go to the forums. The forums are under discuss.itversity.com. And in this, you can start creating any questions in the form of topics. Just click on the topic and choose the appropriate category and post the question. And there are army of volunteers who are answering these questions, and it will help you to get your questions answered as quickly as possible. That being said, thank you very much. I will be stopping this session for and I will be restarting a Hive session in a couple of minutes. Bye.